Good morning, ladies and gentlemen. Today we're going to go ahead and take a look on how to make some specific equations a little bit easier. So we're going to start with the equation 2x plus 3.5 equals 8.5. And as you can see, there's decimals. So we're going to learn the technique that is going to multiply or divide the same number on both sides to every term to make it a different, simpler problem. So when we have something like 3.5, we know that if we double it or multiply it by 2, then that is no longer going to have a decimal in it. It's going to go ahead and turn it into an integer. So we're going to go ahead and we're going to multiply every single term on both sides of our equation by 2. So we know 2 times 2x gives us 4x, 2 times 3.5 gives us plus 7, and 2 times 8.5 gives us 17. At this point, we're just going to solve normally. We're going to subtract 7 from both sides, and that gives us 4x is equal to 10, divide both sides by 4, and we have the answer of x is equal to 2.5. Well, that was a multiplication example. We can do the same thing with example 2, only this time we're dealing with numbers that are really big. So we're going to go ahead and do what we can to divide the same number by every term on both sides in order to make it smaller. So I can see that there's a 0 at the end of each number. So I know that that's divisible by 10. And then I look and I see a 24, 36, 48. I know those are all divisible by 12. So I can go ahead and divide everything on both sides by 120. So that gives me 2x plus 3 is equal to 4. Then I'm going to go ahead and solve it normally. Subtract 3 from both sides. That leaves us 2x is equal to 1. Divide both sides by 2. And I have x is equal to 1/2. Now, this next technique that we're going to talk about isn't really a mathematical technique. It's just a silly way that I look and remember how to solve this type of problem. And I call it the magic unicorn. And of course, that's our magic word today is magic unicorn. So in this type of example, as you can see, we have our variable that we're solving for as the power of an exponent. So we're still solving for x, and we haven't come across this yet. You'll see it again in Algebra 2 using logarithms. But for now, we're going to go ahead and use the magic unicorn to kind of help us learn how to solve this type of problem. So the first thing that we're going to do is make sure that the bases are the same number. Now, in this case, we can already see that our bases, our big numbers, are both the same. They're both 2. That's why it's an asterisk step, is sometimes we do it, sometimes it's already done for us and we don't have to. So when we have the bases the same, then it's time for our magic unicorn to come in and do its job. So our magic unicorn sees that the bases are the same and it gets all excited, and its horn has glitter coming out of it because it's so proud of you for getting those bases the same. And that glitter gets such an amount in the air that it covers up those bases. And when it covers up those bases, the unicorn's done its job and it goes away. Now, step number 2 is to rewrite the powers that remain. The unicorn got all that glitter there, and so basically those bases fade away. And so what we have remaining is x plus 6 equals 5. And all we have to do is solve normally. That's our final step. So subtract 6 from both sides, and we get an answer of x is equal to -1. Let's go ahead and look at a little bit harder example. So example 4, we have 2 to the x plus 3 equals 4 to the 5th. Once again, we're solving for x. The problem here is that we don't have the same base. We have a 2 and we have a 4. So when they're not the same, we need to make them the same. So we look at our bigger number and we ask ourselves, can we rewrite that in a way that has a base of 2? And as you know, 2 squared is the same as 4. So we're going to go ahead and rewrite 4 as 2 squared. The left-hand side stays the same, 2 to the x plus 3, but instead of our 4 here, we write 2 squared. And then we take that power that was there and we put it right next to it around a set of parentheses, knowing, of course, that parentheses mean to multiply. So, oh my gosh, the bases are the same. So in comes my magic unicorn, gets all excited, glitter goes everywhere, we cover up those bases, and the unicorn's done its job, it goes away, and what we have left is x plus 3 is equal to 10. Subtract 3 from both sides, and x is equal to 7. This last example, example 5, is the hardest example that we'll run into, and it's when we can't really have a base that is 9, because 9 squared is 81, which is well above 27. So neither of these can have the proper basis, so we need to rewrite both of them. I know another way of saying 9 is 3 squared, 3 times 3. And I know another way of saying 27 is 3 to the third power. So I'm rewriting both of those so that they have the same power for the base. So the base is going to be 3. And so my left side becomes 3 squared. And remember to put that what's up there already, which is the x, around it in a set of parentheses. I rewrite my 27 as 3 to the third power. And then once again, put my power that was already there in a set of parentheses. Oh my gosh, once again, it's time. Magic Unicorn comes in. It's so happy that the bases are the same, glitter everywhere, exploding, and it goes ahead and it covers up those bases. They go away, they fade away. Unicorn's so proud, it spins and flies out the top, and we rewrite what we have remaining. So we know 2 times x is 2x, and 3 times 8 is 24. Divide both sides by 2, and my final answer is x is equal to 12. Once again, this is just a silly way to remember that when we have our variable and our power, we rewrite the bases the same. Those powers go away. We go ahead and use our magic unicorn, and have a great day, ladies and gentlemen. I hope everyone's doing great. Miss you all.